start that up. Okay, so now we're looking at page 3. So we're going to replace find the conjugate of the following radicals with solve the radical expression. We're going to replace this, and we're going to say this is the square root of 2x plus 15 equals x plus 6. All right, and we're going to replace this with square root of x plus 5 equals x minus 1. All right, so I'm going to do this one. I've got the square root of x plus 5 equals x minus 1. I need to get rid of the square root. Well, when you're dealing with an equation, how do you get rid of something? Well, you do the opposite. But yes, so what's the opposite of the square root? Is squaring. You know, the opposite of square root is taking something to the second power. So I'm going to take this side of my equation to the second power because I'm replacing them. Yep. I'm saying number 7 is going to be solve the radical expression. So I'm not just going to have some problem that's just find a conjugate. Okay, so now I've got this, right? The square root and the square, they cancel each other out. So the left side of my equation is just x plus 5. But see, the right side is x minus 1 to the second power. So you either need to do FOIL or you need to do the box method to get that. I don't know which one you're more familiar with. Let's do the box real quick. I got x minus 1 and x minus 1. X times x is x squared. X times a minus 1 is minus x. Minus 1 and x is minus x. And then negative 1 times negative 1 is positive 1. So when I write that all down, I got x squared minus 2x plus 1. Now, because this problem has an x squared in it, and it's not, that x squared ain't going anywhere, what I'm going to do is I'm going to move all of my stuff to the right side of the equation and then factor. So I'm going to start by subtracting 5 from both sides. So subtracting 5 from both sides gives me x equals x squared minus 2x minus 4. Then I'm going to subtract x from both sides. Okay, so now I'm going to have 0 equals x squared minus 3x minus 4. So now I'm going to factor that. Now, if I can't factor it, then I'd have to use the quadratic equation. So hopefully we can factor this. So I'm going to give myself 2 parentheses. What 2 things do I multiply to get x squared? X and x. What 2 things do I multiply to get 4, but when I subtract them, I get 3? 4 and 1. Because this sign is a negative sign or a minus sign, my signs are different. So the middle term has the sign of the biggest number. Which number is the biggest? So then that's a minus 4 and a plus 1. So my final answer is x equals negative 1 and x equals positive 4. All right. I would suggest you do, but I'm not saying that necessarily you have to. Now, it was just said to me, do we have to check it? The thing is, when you get these 2 answers, you may have an answer that doesn't work. It's called an extraneous solution. It means that you do an extra because your answer that you got that should work doesn't work because of the square root. If I put a negative 1 in for x, I get negative 1 plus 5. That is a positive 4. I can take the square root of 4. No big deal. If I plug in 4 here, 4 plus 5 is 9. I can take the square root of 9. No big deal. But just to give you a for instance, I don't want to confuse you, but just for instance, if I work this out and I got a negative, I'm drawing a blank. I got a negative 7. If I plug negative 7 in here, I got -7 plus 5. That gives me a -2 under the square root. Can't have a negative under the square root. So then that would be an extraneous solution. That would be something that it'd be nice if it worked, but it don't. So everybody follow. So you should check that. I'm probably not gonna hit you with it, but you need to know that that's something you should do. Okay? Does anybody got any questions? That's solve the radical expression. Now, simplifying the radical expression, I'm going to make some slight changes here. First, I'm going to say 1 divided by the square root of x minus 5. And in the second one, I'm going to say 4 minus x over 2 plus the square root of x. Now, all I did was put in variables under the square root, but it makes a slight difference. So we're going to simplify the radicals um, with variables under the square root. Well, in this case, right? If I'm trying to, well, first off, when you have a rational expression, something that's a ratio, something that's a fraction, something that's got a numerator and a denominator, your denominator cannot have radicals in it. So as plain as day, both of these have radicals in it, the square root of x. You can't have that. So I got to get rid of that. All right. So the way we're going to get rid of that is by multiplying by the conjugate of this. So in that, the conjugate of this is the square root of x plus 5. And because we're dealing with a fraction, we got to do it top and bottom. Right. So when I do that, I've got the square root of x times the square root of x. That is just x. Right. And then I've got -5 times +5. That is -25. Now, see, the thing that's important to remember about this, I don't want to confuse you, but I need to at least go there for a moment. That if you've got the square root of x minus 5 times the square root of x plus 5, usually when you take two binomials and multiply them, you get a trinomial. But when you take two binomials that are conjugates of each other, the middle term cancels off. All you get are the end terms. So you get the square root of x times the square root of x, and then -5 times +5. So that's why this works, because the middle terms to this would be square roots, and I'd still be in the same boat. So now I take 1 times this, and I get the square root of x plus 5. Now the thing is this, it doesn't matter that I got a square root in the numerator. Having it in the top, no big deal. It's having it at the bottom that's a problem. So this is my final answer. Now this one's a little tougher. The conjugate of this is 2 minus the square root of 4. Square root of x, excuse me. So I'm going to multiply that. If I multiply that in the denominator, 2 times 2 is 4. Positive square root of x and negative square root of x give me a negative x. So that's that, no big deal. But on the top, it gets a little meaner. I'm going to use the box method so I can explain it. So I got 4 minus x and 2 minus the square root of x. So when I multiply 2 times 4, that's 8. When I multiply 2 times negative x, that is negative 2x. When I multiply the negative square root of x times 4, that's negative 4 square root of x. And then if I multiply negative x times negative square root of x, that is positive x times the square root of x. All four of those things are not, none of those are like terms. So I would just write it all out. And that would be my answer. There's no simplification to do. Not cute in the least, but that's what I got. Does anybody got any questions? All right. The last one for this page is actually dividing. You got long division, you got the tabular method, or you got synthetic division. I think we can all agree that synthetic division is probably the easiest. So that's what you should use. So what is my A? What am I going to divide by? Right, now just so we're clear, when you do synthetic division, you need to think about this form, x minus a. Well, that's not x minus a. So to change x plus 7 to x minus a would be to change it to x minus a negative 7. Because when you subtract a negative, it becomes a positive. So like the man said, my a is negative 7. So synthetic division. So now I've got 6, 20, 5, and negative 21. So I'll bring the 6 down. Negative 7 times a positive 6 is negative 42. So 20 and a negative 42 is a negative 22. So now I got negative 7 times a negative 22. Yeah, this is ugly. So that's 14 carry to 1. That's 14, 15. So that's a positive 154. So when I combine those, I get 159. And then next, I need to multiply. Negative 7 times this, so that's a negative. Negative 7 times 9 is what, 63? And then carry the 6. 7 times 5 is 35. Plus 6 is 41. Carry the 4. So that's 1113. E. And then I combine these, and that's going to be 4, 3, 1, 1. So it is definitely not a factor, but that's not what the problem said. It said find the quotient. So I started with x to the third power, so this is going to be x to the second. So that's 6x to the second minus 22x plus 159 minus 1134 over x plus 7. That's my answer. You put the remainder over whatever you divide it by. That's how you do synthetic division when you got a remainder. Does anybody have any questions? All right, and let's call that